Hello everyone, welcome back to our next lesson. We're going to finish up right now an example involving finding the roots, the complex roots of an equation using de Moivre's theorem. So this is example B on the bottom of page 26 in your textbook. Let's have a look at the equation that they want us to solve. There's the equation right there. So it's not just a number this time, it's an actual equation. So the first thing we need to do is to get the x, the variable, by itself in this equation. So if I take the equation and bring my 16 to the other side first, I'm going to have x to the power of 4 equals 16. And of course, to get the x by itself, I would have to take the fourth root of both sides. So you're going to have x is equal to the fourth root of 16. And if we write that as a power, as an exponent, that becomes 16 to the 1 over 4. Now the question I suppose arises, how many roots are we going to have here? Well, notice that it's a fourth degree polynomial equation. The largest power of the variable is 4. And that tells us right there that there are going to be 4 solutions, 4 roots. And also notice that we have to take the fourth root of a number, and that also indicates that there are going to be 4 of these roots. There are 4 fourth roots to any equation. So the first thing we should do right now is take the number 16, only the 16, which we can think of that as a number in rectangular form, a complex number. It's the same thing as 16 plus 0j, you see. Same thing. So we have to change that into polar form to be able to use de Moivre's theorem. You don't really need, in this example, in this case, to go ahead and use the formula for r to calculate r or to calculate theta, because this is another one of those simple cases. Just think of your real axes and your imaginary axes. Where would 16 plus 0j end up if you were to graph it? Well, in fact, it starts from 0, 0, the origin, and it points exactly along the positive real axis. The length of that vector is 16, and the angle that it forms is 0 degrees. So 16 is actually the same as, there's my r value, 16, angle symbol, and we have 0 degrees. There's the number in polar form. So that's what we need to take the fourth root of. So root number 1, here's your first calculation. You want to take 16, 0 degrees, and raise that to the power of 1 over 4. And when you do so, of course, remember the way de Moivre's theorem works. You actually take the fourth root of 16. Well, that's easy enough. That's just going to be 2. And then you multiply the angle by 1 over 4. So what you end up with is 2, that's the fourth root of 16, angle symbol, 0 degrees. So there's your first root, there's your first solution. Now remember though, this is actually in polar form. The original number, 16, was actually in rectangular form. So if you were to change this into rectangular form, and remember how you do that, you need a plus bj. A is equal to r times the cosine of theta. So that would be 2 times the cosine of 0 degrees. So I believe that's equal to 2. And you also have to get your b, which is equal to r times the sine of theta, and that becomes 0. So when you type both of those calculations into your calculator, it turns out that in rectangular form, the first root is actually 2. Now you probably suspected that because 2 actually is the fourth root of 16. That should not be a surprise. Now we have to calculate 3 more roots. And remember the technique we do to calculate the other 3. You basically add 360 to the angle that you used in your first calculation. So the next calculation is 16 angle symbol. 0 plus 360 is 360. And you raise that to the power of 1 over 4. So again, that becomes 16 to the 1 over 4. And you multiply 1 over 4 times your 360. So what that will give you is, again, 2 angle symbol. And 1 over 4 times 360, now you get 90 degrees. So there is the second solution, the second root in polar form. Now if you change that back into rectangular form, remember a is equal to 2 times the cosine of 90, and b is equal to 2 times the sine of 90. And what you're going to end up with is a becomes 0, b becomes 2. So that means the second root is actually 2j. There's your second solution. Now if you take your calculator, put it into complex mode, and put 2j inside of a set of brackets and raise it to the power of 4, that should be equal to 16. You can even do the calculation manually. Third root. We have 16 again, angle symbol. Now add 360 to the 360 in your last calculation. So that becomes 720 to the 1 over 4. So again, 16 to the 1 over 4, which is 2, angle symbol, 1 over 4 multiplied by 720. So that will become 2 angle, and 1 over 4 times 720, I do believe, is 180 degrees. So there is the third root in polar form. And again, if you go ahead and do the simple conversion to put that back into rectangular form, what you're going to get in this case is -2. So there's the third root. And we have to find one more. So the last root, number 4, is still going to start with a 16. Add 360 to the last calculation that you used, the last angle that you used. So that would be 360 plus 720 is 1080 to the power of 1 over 4. So in this case, you're going to get 16 to the 1 over 4, angle symbol, 1 over 4 multiplied by 1080 degrees. And so what you will get in this case is 2 angle symbol, and 1 over 4 times 1080 should be 270 degrees. So there is the fourth root in polar form. And again, now if you go ahead, change that back into rectangular form, calculate your a, calculate your b, what's going to happen is a is going to be 0, b is going to be -2. So the fourth and final root in rectangular form is -2j. And now you stop, because you have found all 4 of the roots, of the fourth root, sorry, of 16. In other words, you have found all 4 solutions to that original equation up there. And remember, there's not 5. You would not continue this for another step. You would just stop right there. Again, I'd like to stress that it's very important you read the question carefully, because if this question had said, leave your answers or leave your roots in polar form, then these numbers here, they would have been sufficient. You would not have had to convert it back into the rectangular form. So what I'm going to do now is leave the questions on pages 27 and 28 for you to try. This is the last part of unit number 1 here now. Let's just have a look at the questions before we finish the video. I'd like to ask you for these practice questions, how many solutions or how many roots do you think each of these things are going to have? So on practice 15, page 27, part A, it says find the square roots of the equation. Well, there's not really an equation. It's just a number. It's just an expression. So find the square roots of, and by golly, look at that. That number is already in polar form. In fact, if you wanted to, you could even write it as 4, angle symbol, 60 degrees. That would be the condensed polar form. And there's nothing wrong with doing it that way if you'd like to. So there's only going to be 2 roots, 2 square roots for any number. Part B says find the cube roots of, and again, it's not really an equation, it's just a number. So find the cube roots of 3 minus 4j. Well, this number is in rectangular form. Your first step would be to change it into polar form. So you do require the calculation for r, and you do require the calculation for theta. Be careful, though, because when you're calculating theta, note that 3 minus 4j, if you were to graph that, would be somewhere down in quadrant number 4. So your calculation, your first initial calculation for the angle, would actually give you the reference angle. All right, inverse tangent of 4 over 3. You would have to subtract that from 360 to get your theta. So be careful with that. Okay, but cube roots, there's going to be 3 of them. Now, C is an equation. X to the power 4 subtract 1 equals 0. That, ladies and gentlemen, is going to have 4 solutions. There will be 4 because you're going to be calculating 4th roots for this example right there. On page 28, you have x to the power of 3 plus 27j is equal to 0. Again, you're going to have to get your x by itself. Cube roots are going to come into factor here. You're going to find 3 solutions to that equation because it's a degree 3 equation. E, oh my goodness, look at that. X to the power of 5 plus 32 is equal to 0. That's going to have 5 solutions. So make sure you calculate all of them. And F then, on the bottom of that page, x to the power of 4 minus j is equal to 0. That is actually going to have 4 solutions. So you try those. Make sure you check the answers on D2L. They will be posted very, very soon. Also, you will notice that on pages 29 and 30, there's page 30, page 31, and on page 32. Some very good practice exercises, some review exercises for you to try, because this marks the end of unit number 1. All right. So anyway, try those practice questions. Try the review questions as well, the extra practice. Check your answers on D2L. If you have any problems or any questions, make sure you pop me an email. And that's it for this video. Thank you very much. The next video will be on unit number 2. Okay, bye-bye.